Number 3, here we go. Roller coasters with larger maximum heights usually go faster than shorter ones. A linear regression was calculated using data from 9 roller coasters that opened in 2012. The equation of the regression line for this relationship is y hat equals 28.17 plus 0.2143x, where x equals height in feet and y equals maximum speed in miles per hour. A, what is the explanatory variable and what is the response variable? How do you know? All right, so the explanatory variable is going to explain changes in the response variable. So I got two variables to choose from. Got x and I got y. X is height, y is maximum speed. Which explains which? Well, I think it would be more reasonable that height explains the maximum speed of a roller coaster. The higher you go up, the faster you're going to go. Maximum speed explains height doesn't really make that much sense. Another way you can look at it is that the explanatory variable is always going to be the x variable, and the response variable is always going to be the y. So that's another kind of thing. So either or. So the explanatory variable is height, and the response variable is going to be maximum speed. So you can say that the x value the x variable is explanatory and y is response. Good. There we go. Simple as that. Alright, let's go to B. In a partner amusement park, a roller coaster is 30 feet tall. Make a prediction using the regression line as to the maximum speed of the roller coaster. So I want to make a prediction, so it's giving me an x value, which is 30 feet, and it wants to know what the prediction is. So it's just plug and chug. So it's going to be y hat equals 28.17 plus 0.2143 times x, which is going to be 30 in this case. Right? Time to get that calculator out. 0.2143 times 30, 6.429. Okay, bring everything down. Okay, add them together using your calculator, and we get 34.599. And what is this going to be miles per hour, I think, right? So this is our prediction. All right, for C, it is revealed that R equals 0.113 for this regression model. Does this increase or decrease your confidence in the prediction you made in B? Why or why not? Assume your calculations are correct. Well, 0.113 is very close to 0. It is a very weak correlation. So this should decrease our confidence. 0.113 is a weak relationship. Meaning it doesn't really do a good job at prediction. And boom, all right, back. Sorry for the interruption. Go ahead and finish the job. Again, 0.113 is a weak relationship. So it's not going to be a really good prediction. It's going to be a very weak prediction. Number 4. In a certain population, there is an approximately linear relationship between y equals height of females in centimeters and x equals their age in years, described by the equation y hat equals 50.3 plus 6.1x. A. Identify the y-intercept and slope for this regression model. So y-intercept is what is y when x is 0. So when x is 0, this goes away, and then you have only 50.3 remaining. You can also use the formula for a regression line, which is in your vocab. A is your y-intercept, B is your slope. So y-intercept is going to be 50.3, and the slope will be, let's see, 6.1. Excellent. All right, let's look at B. Does the value of the y-intercept have meaning in this context? If so, interpret the y-intercept. If not, explain why. So in this context, remember, what is x? X is their age. So when x equals 0, meaning their age is 0, what is y? Y is 50.3 centimeters. So in essence, if you're 0 years old, you're basically a newborn, right? So we could say this as baby females are predicted to be 50.3 centimeters tall. All right, finally interpret the slope. Once again, slope is rise over run. Okay, in other words, it's your change in the triangle means change in y over change in x. What is y? That's going to be the height, so the change in height over the change in their age. And what is the slope? 6.1, so this is 6.1 divided by 1, right? So for every 1 year increase in age, they grow 6.1 centimeters. For every year females are predicted to grow 6.1 centimeters. Alrighty, here we go. That is it for this page. Thank you very much for watching. Hope you all have a great day.